So I really love harmonographs. I was first introduced to the idea of harmonographs, I think in high school by a friend of mine who had built a contraption to kind of draw these things out. And then a number of years ago, I found, I want to give a quick plug for this because WorldTree Software, just one user, I can't even tell you who exactly this is, built a virtual harmonograph that over the years I've had a lot of fun playing with, and that's what I'm going to use in this video. So I really encourage you to go to the site, check it out. There's both a virtual online version and a downloadable version that you can install just because it's what I'm used to. The interface is basically the same. I have downloaded it and installed it here, but I want to give an introduction, not just to using this, because you can click this and open it up and hit random numbers in there and get something, but I want to give an introduction into what is a harmonograph and what is harmonic motion kind of generally, and what can you do with a harmonograph once you have a little bit of sense of control over it. Because like I said, you can plug numbers in and the random images, harmonograms that it generates are interesting and cool, but when you get a little control, I find it to be, well, to me, a little more enjoyable, and I get, like I said, a little more control and a little more predictable of an outcome here. So I'm going to start here just by opening the settings. The kind of eject button up here is how you open the settings. By default, usually when you open this up, it has a few different pendulums in here. I'm going to explain what these are a little bit, but I'm going to actually remove all of them except the pen color, which is going to give us a little bit of color changing here, and the x-axis, because I want you to see just what is happening in here. When we change the visualization options, I'm going to turn this way down so that you get to see sort of how is this thing moving. You might see sort of a back and forth. If I put a little bit of a decay in here, let's add a little more of a decay, like 0.2. And then if I even kind of zoom in here, you can see as it goes back and forth, we get sort of a decay of how this, a little less decay in here. Notice it goes back and forth and back and forth. And I have the color change in there so that the pen is changing colors as it goes. And you might see that this is really just what a pendulum would do if we were to to have it just swing back and forth, right? So you can see it swinging back and forth, changing color as it goes, right? And that's not really interesting. What starts to get interesting is if you say, okay, I have this pendulum that swings side to side, back and forth, but what happens if I have it swing forward and backward at the same time? So I'm going to add another pendulum. X-axis is that's just side to side. So we can think, okay, I've got something that swings side to side, but I want it to swing up and down also. And I'm going to have it do it really in the same way as the X. So the amplitude is 1, the frequency is 1, and I'm going to put the decay even the same because it starts to do some funny and kind of interesting things. And then the phase, I'm going to cut that out. And so we'll have the phase the same on both of them. And you'll notice now we have something that's kind of moving up and down while it's moving side to side. So it's moving kind of diagonally, but they can move up and down at a different rate. So if for example, rather than starting back at a corner, if it's still moving up and down, but if I have, let me just put enough of a difference on it here. So now it's sort of pushed to the side a little bit. Now it's swinging in a circle. Let me turn the opacity up here so we can get a little more color in there. So you can see how this is now rotating in a little more of a circular motion, okay, which is sort of what you expect as you add another pendulum, where you get a left and a right and a forward and back, and it's swinging sort of in a circle. But where harmonographs really start to get interesting is when something is swinging in one direction at a different rate than it's swinging in the other direction. So for example, if it's swinging twice as fast side to side as it's swinging up and down, what we're going to see is that the side to side is going to go faster and the up and down is still going to be going at the same rate that we've been watching it. So notice it's going side to side twice as fast, but it's still going up and down at the same rate. And we're getting this sort of, it's called a Lissajous curve, this sort of figure 8 pattern. But that figure 8 pattern can change also, because remember how I had changed this phase. They're out of phase a little bit, right? So we can flip it around that way, or you can have, well, like I said, you can play with this all sorts of ways. And you get a little, you can straighten out your figure eight. You can actually, if you set the phase at half of a radian, like a pi radians off, then you get sort of almost like an arc shape, a U shape, right? And then it gets even more interesting, because right now this is going twice as fast exactly side to side as it's going front to back. But I want you to see what happens if we change this and it's off a little bit. Now, I don't want to go twice as fast. I'm going to go just a little more than twice as fast. Okay? And what you'll see is that, actually, let's start here. If we start with that circle, right? So remember, here's our circle, or our ellipse here. But if I move this frequency off, you'll see that it starts in that loop, but you'll notice it doesn't stay exactly in that loop. It's kind of moving off of the loop. The shape is changing just a little bit. Let's speed this up. If we increase the block size, we'll go 10 times faster now. You'll notice how it starts to kind of curve the opposite direction. If I change this even more, right? So now we're even more off. The frequencies are a little more off. It curves even faster in that direction. And we can kind of move more off, and you can actually go sort of piece by piece and see how this gets closer and closer to that ellipse. So now this is 10% off, right? And that jumped pretty quickly, which if we went like little piece at a time, we would see how it gets there. And eventually, right, that gets us, here's our 2 to 1, right? And if I put this just a little off, there's that U shape, sort of decays down into that U shape. And then it would actually switch back the other direction. So let's decrease the decay. By decreasing the decay, what happens is that it doesn't shrink down like a pendulum, right? Decay is how quickly it slows down and stops. So I want it to swing for longer before it really slows down and stops. So I have that phase that's a little bit off. Our frequency is about 2 to 1, but it's a little off. So you see how it's kind of changing directions. We're changing back and forth from blue to green. And we're getting sort of a much more interesting pattern that's happening here, just by changing how quickly it goes from side to side or from front to back, and changing that frequency just a little bit. So this is just with 2 pendulums. We have a side to side and a front to back. If you check out a number of videos, if you search for other videos of harmonographs, you'll actually see people who've built them various ways. You can have actual swinging pendulum harmonographs. You can have ones that draw, which is one that I built that uses a pen and draws across the table using pendulums that swing below the table. But there are other pendulums that we can add here. So we can actually add a rotation pendulum. Right? And a rotation pendulum is, imagine that we take the whole drawing, and as it's drawing this, the drawing is turning around. The whole table is rotating. That's what this is going to do. So it's taking the same thing, and it completely changes sort of the nature. You can still see how it almost has that same sort of shape. The decay is happening, but it has just this consistent rotation as it's going around. And then you can change the decay on the rotation, so you can have no decay on it, so that it kind of keeps spinning at the same rate. This is a really slow decay. I could speed the decay up quite a bit. And so now it's going to actually change how it rotates as it goes on further and further and further. And with every little change that you make, you make sometimes a very drastic difference in the harmonogram, that's the drawing that's produced, that comes out the other side. For students, probably especially pre-calculus, calculus students who are looking at motion, physics students who are learning about just sinusoidal motion, if you're learning about parametric graphs, right? This is really, when we're talking about, especially in the aspects when we're talking about an x-axis and a y-axis, how we're moving side to side while we're moving front to back at the same time. That's a parametric graph. You have a sine wave going side to side. You have a sine wave going up and down, or the perpendicular direction. But then the other thing that you can do here is I have these different figures on here. I can just randomize them all. I generally put the amplitude on 1 for both of these, because if you don't, it draws off the canvas here. But like I said, you just get really interesting sorts of like, you could spend so much time. I mean, there's really advanced mathematics work that's involved in just frequencies. If you start heading down the rabbit hole of researching how do frequencies match up with each other, how do we map different types of graphs onto each other. So if you have like a parametric graph versus just can you map that onto a function or onto a polar coordinate system, polar coordinate plane, and many different, like I said, many different ways to kind of look at this and think about this. But I wanted to at least throw that out there as a way to introduce you to the idea of harmonographs and harmonograms. Go check out what else is out there. Thank you so much for watching.